Hello, welcome back to Mrs. Torres' YouTube channel. Today we're going to start chapter 7. What we're going to do is we're going to be taking different roots, so that could be square root, cube root, fourth root, and I think there are some fifth roots in there, of numbers with variables. Before we get to that, let's think about how we would simplify the square root of 200. We would start with our factor tree, right? So 2, 100. I circled 2 because it's prime. 2, 50, 5, 10, 2, 5. So the square root of 200 is really the square root of 2 times 2 times 2 times 5 times 5. I just rewrote all these numbers. When you're simplifying square roots, you look for pairs of numbers. So here's a pair of 2's, here's a pair of 5's. When you have a pair of numbers, they become 1 on the outside. The reason is because if you have the square root of 5 times 5, and we would do the math. 5 times 5 is 25. Square root of 25 is 5. Taking the square root of something is asking what number times itself gives us this number. So if you're taking the square root of two numbers multiplying together that are the same, it's just that number. So on the outside we have a 2 times 5, and this 2 does not have any pairs. So that guy stays underneath, and it simplifies to 10 root 2 as our final answer. That's essentially what we're doing, except we're going to throw some variables in there and some higher roots. So let's look at this one. The square root of 392 x to the 6th y to the 5th. So we start the same way we normally do. Let's work with 392 and do our factor tree. 392 is an even number, so we know we can divide it by 2. So 2 and 196. 196 is again even, so we can split that up into 2 and 98. Look at that, 98 is even. 2 and 49. 49 is 7 and 7. So you don't have to write this every time you do it. You can just look for pairs on your tree if you're more comfortable doing that. So I have a pair of 2's, so that gives me a 2 on the outside. Then I have a pair of 7, so that gives me a 7 on the outside. And I have 1, 2 that has no pair, so he stays underneath. So this simplifies to 14 root 2. I'm going to put this up here. And then what I'm going to do is I'm going to think about the x's. So x to the 6th. Instead of doing a factor tree this way, what I'm going to do is I'm just going to expand x to the 6th. X to the 6th means we multiply x by itself 6 times. So x, 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 x. Then again, just like we did with this factor tree, we look for pairs. So we've got pair of 2's, not pair of 2's, sorry, pairs of x's, pair of x's, pair of x's. That means x to the 6th simplifies to, sorry, the square root of x to the 6th, I should say, to x cubed. So I'm going to add that to our answer up here. Then let's think about the y's. The square root of y to the 5th, that's just 5 y's, right? Then let's look for pairs. 1 pair of y's, 2 pair of y's. 1 is all left by itself, so he stays underneath the square root. So y squared times the square root of y. Then we just got to put our 3 parts together. So 14 x to the 3rd y squared, that's all on the outside, and the square root of 2y. That is our final answer. So this and this are the exact same thing. This is just the simplified version. Now if we take a look at how we got from the square root of x to the 6th to x to the 3rd, all we really did is take this exponent and divide by 2, right? 6 divided by 2 gives you 3. Here, we divided 5 by 2, and we got 2, but we would have 1y left over. So that's kind of a shortcut if you don't want to write these out every time. For the first few, you can, just to get the hang of it. All right, let's take a look at another one. How about the cube root, this time, of negative 250 x to the 4th, y to the 8th. So, whenever you have a negative under the square root, what I want you to do is just pull out a negative off the bat. So we're going to have a negative 1 on the outside of our cube root, because the cube root of negative 1 just gives you negative 1. So we can pull that out right away. And then we'll just do our factor tree and ignore the negative for now. So we'll have 10 and 25, 2 and 5, 5 and 5. So up here in these two examples, we were taking the square root. So we were looking for pairs, right? But here, we're taking the cube root. The cube root. So that means instead of looking for pairs, we're going to look for groups of 3. So right here, we have a group of 3 5s. And this 2 is left all alone. So it's the cube root of 2. So really what we have is negative 5 root, don't forget that cube in there, let me rewrite it, negative 5 times the cube root of 2. Make sure that it's very obvious that there's a cube root there. So you got to write very clearly here. Now let's look at our variables. So we have x to the 4th. X times x times x times x. Since we're taking the cube root, we're going to look for groups of 3. That group of 3 becomes 1 on the outside. So this is going to be x times the cube root of x. Then we look at the y's. 1, 2, 3, 4, 5, 6, 7, 8. Let's look for groups of 3. There's 1. There's 2. So this would simplify to x squared times the cube root of x squared. Because there's y. There's 2 y's left underneath. Then we're just going to combine everything. So on the outside we have a negative 5. We have an x. And we have a y squared. And then we have the cube root. Make sure it's very obvious that it's cube root of 2xy squared. Now if we look at how we got from the cube root of x to the 4th to x cube root x, if we divided 4 by 3, we would get 1 with 1x left over. If we divided 8 by 3, we would get 2 with 2 left over. So that's how you can kind of do this in your head without having to expand all of these. Let's do one more example. This time we're going to take the 4th root of 64x to the 3rd y to the 10th. So let's do our factor tree. I know 64 is 8 and 8. 8 is 2 and 4. 2 and 2. Lots of 2's for this one. So we have 1, 2, 3, 4, 5, 6 2's. So 1, 2, 3, 4, 5, 6. Now, since we are taking the fourth root here, we're looking for groups of 4's. So there's 4 2's. So that's going to be 1, 2 on the outside. And the fourth root of what's left without a group? A 2 and a 2. So there's a 4 left underneath there. Then let's look at the x's. X to the third is x times x times x. Are there any groups of 4 here? No, there's not enough x's, right? So no groups of 4. So this can just stay as the fourth root of x to the third. We actually can't do anything with that one. Then we look at y to the 10th. Let's try and do this one without expanding it, just like using our division. So if I divide 10 by 4, if you can't do it in your head, you can absolutely use a calculator. So 10 divided by 4 gives you 2. So that means that there's going to be a y squared on the outside. It says 2 groups of 4 in here. If I took 2 groups of 4 out of here, 2 times 4 gives me 8. So that means I have 2 y's left over that don't have a group. So that's how you can do it without writing them all out. Oop, and don't forget my little 4 there. Almost forgot. And then we just combine everything. So on the outside we have a 2y squared. And then we have the fourth root of 4x cubed y squared. All right, that is it for today. Go practice.